Hello friends and welcome to a lecture on Python. Today we will learn how to use Python program or how to write a Python program to find the roots of an cubic equation using Newton-Raphson method. Now the equation is written here. It's 12x cubed minus 59x squared plus 79x minus 30. Now the roots are 2 by 3, 5 by 4 and 3. Of course, we'll be using Newton-Raphson method to find these roots. The Newton-Raphson method estimates the root using the equation xn plus 1 is equal to xn minus fx over f dash x. Now, let us say if xn is the old estimate of the root. Now, the new estimate of the root xn plus 1 is xn minus f of x. That is the value of the equation at xn over f dash x, that is the value of the differential of this equation at xn. Now let's get ahead with doing it. So first what you have to do is you have to import SymPy. Then you have to import from SymPy. So you write from SymPy dot abc import x comma y comma z comma a comma b comma c. So this imports the symbols, and then from SymPy import star. So this, the third line, it imports all the functions from SymPy. Now what we do is we write our cubic equation. So we write a variable cubic equation is equal to 12x cube minus 59x square plus 79x minus 30. Okay, and we see what is the output of cubic equation. So there we get the output. Okay, so we missed 59x square x cube minus 47x. Okay, so we have missed something here. So let's check it. 12x cube minus 59x square. So that's square. Okay. And then afterwards it is plus 79x. Now let's check it. X cube minus 59x square plus 79x minus 30. So let's see. Okay, I have missed one more star here, and that should do the job. So now we have the output. And then if you want to find the value of this equation at any point, then it's done this way. Value is equal to cubic equation dot subs, that is short for substitutes, x comma 2. Now this will calculate the value of this equation at 2. So let's check the value, and we get that the value is 12. Now the value of the differentiation, that is the differentiation of this equation, can be easily found in Python. So we write diff, a variable, we define a variable diff is equal to diff. Let's do it slightly different. So we find diff of equation so that we don't mix up things. And in Python you have to write diff, diff, then write the name of the equation, that is cubic equation, and the differentiation with respect to which variable do you want. I want it with respect to x. Now let's see what is diff of equation And as we can see, it has differentiated the equation and given it to me. Now, of course, if I want to find the value of this, again, diff diff of equation dot subs subs, that is the value of this differential at x is equal to 2. So we write diff diff of so this will display the value itself at that point, and you get it as minus 13. Now let's start programming for the Newton-Raphson method itself. So let's have a look at it first. It says that the new estimate of the root is equal to the old estimate of the root plus the value of the function at the old estimate divided by or over the value of the differential at the old estimate. So let's start programming it. So what we write here is now cubic EQN equation dot subs subs, and then we write x comma a old over diff, that is the differential of the cubic equation with respect to x, and of course the value of that at a old. Having written this, let's add now minus let's put equal to here and write a new. So we have here a new is equal to a old minus the value of the function at the old estimate over the value of the differential of the function at the old estimate. Now let's do something here. Let's insert a cell above this and let's check this whether this is working or not. So let's write a old is equal to 2. And of course we have estimated a new here. So let's run this. Let's run this cell first. So we run it and then we run this cell and then we see what is a new. Yes. So a new is the next estimate, right? Now the further estimates is going to be done by taking the a old equal to a new, right? I'll explain this here. Once we get xn plus 1, we again have to take this value of xn plus 1 and put it here in place of xn and evaluate the functions at xn plus 1. So we will get xn plus 2. Now take xn plus 2, put it here and evaluate the functions at xn plus 2. You get xn plus 3. So this requires a for loop in Python, but what we can do here is we can use a while loop to do it. And I'll show you how to do it. Now this is known as the inside out method, where first what we do is we write the equations that is going to go inside the loop and test them once and then finally write the loop. So let's create space and let's first define a variable known as delta is equal to 1 and let's just give it a value of 1. And then we write while delta delta is greater than 0.001. So this is the tolerance, right? So we tab it here. So what it will do is now, I'll further clarify this, write another statement. And what we do here now is we write delta is equal to ABS, that is the absolute value of a new minus a old. And the next statement that we write is A new is equal to A old. We are done. And it's ready. Now what does this do is that during each iteration, it calculates the difference between the old and the new roots. Now, if the difference is greater than 0.001, the while loop gets executed continuously. The moment the difference is less than 0.001 or equal to that, it will terminate this loop and it will give us the value of the root. So we now write print the root is okay. I need to make a slight change here. We have to write A old is equal to A new. That is, we get the new root and then the old root, that is, it is replaced with the new root. And now let's run this. So having run this, let's delete this off. Okay, so let's run this now. Well, let's put it in float. So this will give you the decimal value, and there we are. We have got 1.25. So this gives you the root 5/4. Now, if we start with a close estimate to 0.666, which can be 0.01. And let's run this. So we have to run both the cells. So we have to run this cell first, run, and the subsequent cell, run. And it gives you an estimate of 1.25 once again, right? So we have to change this now, 0.01, run this, and run this. And as we can see here, we have come to 0.66666. Similarly, if we take a value of 5, run, 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 and run, we come to a value of 3. So that was all about how do we program for Newton-Raphson method. Hope you have understood. It's a very simple program. Now this is Newton-Raphson method, of course, for finding out the roots of an equation of a single variable. For a multivariable, keep watching. I'll be putting the video soon. Goodbye, friends. Have a great day.